how it works.
Okay, action.
This video goes out to Christy and Monet for recording my video. We are going to talk about the Year 10 practical, which is about osmosis using potato cores. We have to know the independent variable and the dependent variable to make our hypothesis. The independent variable is the concentration of salt in the solutions. The dependent variable is the weight of the potato cores. The hypothesis is what you think will happen. Control variables are things that you want to stay the same. Provide you with validity. That was from Sam.
Yeah.
We're going to repeat it so that we get reliability. All right, we're going to take potato cores. We're going to use a potato corer. We're then going to find an initial weight. At the end of it, we're going to find a final weight. We're going to use kitchen scales to measure that. Then we're going to measure the change in weight, and from that, we're going to measure the percentage change in weight. Just taking the final and the initial weights is called primary data. When we manipulate it, it becomes secondary data. The equation we use to calculate percentage change in weight is the final weight divided by the initial weight times 100. That gives us a percentage, and this normalizes the data. Let's stick that bit out. Right, so here is the graph we will get from the experiment. On the y-axis, we're going to have the percentage change. On the x-axis that runs through the middle of the graph, we're going to have the salt concentration. At 0% salt, which is distilled water, we should get the most mass increase. This is because water is going to flow from the 0% salt solution into the cell. So the 0% salt solution is going to be hypotonic. The cell is going to be hypertonic, and water is going to flow in, make it increase in weight. When we explain it, we say that the net flow of water is into the cell. It's moving from a hypotonic environment, which is outside the cell, to a hypertonic environment that is inside the cell, along the osmotic gradient, through the cell membrane, which is semi-permeable, and it's passive, which means that it does not require ATP. The cell membrane is semi-permeable because it allows water through but can stop the salt going through. Okay. Down the bottom here, the potato cores are going to lose weight, so we can say that the water is going to move from the cell into the 10% salt solution. We can say that the cell is hypotonic and the 10% salt solution is hypertonic, and water will move out of the cell. When we write it up, we say that the net flow of water is out of the cell from a hypotonic environment, which is inside the cell, to a hypertonic environment that is outside the cell, along the osmotic gradient, through the semi-permeable cell membrane, and it's passive. The trick to this prac is to work out where it is isotonic. And it's isotonic when there is no net gain or loss in weight, which is where it crosses over the x-axis.